Hi guys, Jake here. After we created a mobile controlled app, now we need to create an app that will receive all the commands and control our car. Before we start, if you like this content, please leave a like and subscribe to help this channel grow. All source code is available on the project's GitHub. I will leave you a link in the description. Let's start by finding a way to synchronize code between Visual Studio Code and the Raspberry Pi. I tried to use some plugins for synchronizing project via FTP, but they didn't support TLS connection. However, luckily, WinSCP has a built-in synchronization any folder the remote server. Okay, let's start writing our Python project. But before that, let's learn the Python.
2 hours later.
Okay, let's start creating our Python project. Let's start with a simple config file which will contain configuration for the steering servo, driving motor and handbrake motor. Then just create a simple infinite loop so script execution never stops. Then just create base object class for all classes that will benefit from the loop updates. The class that will benefit from loop updates will be a controller class. That will be the main class that receives commands and executes them. Currently there are 4 commands: drive, steer, pull the handbrake and release the handbrake. To make them work, we need to control our circuit. We need the Gpio Manager for this one, which will take care of setting up pins. Then just add 2 classes, Gpio Motor and Gpio Servo, for steering DC motors and servos. Gpio Motor is a simple class that sets up DC motor in 100 Hz frequency. The frequency is not that important. What I wanted to achieve by this is the possibility to steer the speed of a rotating DC motor. Setting up too low frequency won't make DC motor that responsive, while setting up too high won't allow Raspberry Pi to send that precise signal, and the motor will work only on a fraction of its power, except when it's set up to full throttle, meaning the signal is constant binary 1. Gpio Servo is a class for steering a servo. In this case, frequency is automatically calculated by the pulse signal duration in config file. It also supports a value shifting in case that we need to change the value range, as I mentioned in the video about creating an electrical circuit. Now just create a Bluetooth connection manager that will receive commands and we are done. Just add some fail-safe mechanism like emergency stop in case our RC car will drive out of the connection range. Behind the scenes I added the Handbrake Button to our Unity app, as I couldn't bind it to the volume buttons. I also pinned the handbrake DC motor to pin 16 and 18. And that's all, we ended up with fully working communication between our smartphone and a Raspberry Pi. Thank you for watching, don't forget to like and subscribe, and see you next week when we start to design our car.